Now in this question we have to prove that tan raised to power 4 theta plus tan square theta is equal to secant raised to power 4 theta minus secant square theta. So first of all I'll just start with the LHS, which is equal to tan raised to power 4 theta plus tan square theta. So this is the LHS. Now we know that we need to get it to secant raised to power 4 theta minus secant square theta. Am I right? So first of all, one step is very clear, that we will first of all take tan square theta common. So this will be tan square theta plus 1. Now why did I do this? Because I knew that the bracket here will be tan square theta plus 1, which is equal to secant square theta. So we will now get into secant square theta with our equation. So now over here what do I do is I write this tan square theta as secant square theta minus 1 into tan square theta plus 1 is secant square theta. Okay, now this becomes, I'll just multiply or open these brackets, so this will become secant raised to power 4 theta minus secant square theta. Am I right? This is the RHS. So RHS is equal to LHS, hence proved. Right? Now the second part of this question says, I'll just write down the LHS. It is equal to sine A minus sine B upon cos A minus cos B plus cos A minus cos B upon sine A plus sine B equal to 0. Now from here what happens is that over here there is a plus sign, not a minus sign. Now this will be sine A minus sine B upon cos A plus cos B plus cos A minus cos B upon sine A plus sine B is equal to 0. This is what we need to prove. So now what happens is that we first of all take the LCM and cross multiply. So what do we do is that we take the LCM. LCM is equal to cos A plus cos B into sine A plus sine B. Am I right? This is the LCM. Now this term over here becomes sine A minus sine B into sine A plus sine B plus cos A minus cos B into cos A plus cos B. Am I right? This is the numerator. So now let's have a look at the numerator. It is this over here, from here to here, is equal to A plus B, A minus B into A plus B. So this is equal to A square minus B square. So this over here becomes sine square A minus sine square B into plus cos square A minus cos square B upon cos A plus cos B into sine A plus sine B. Clear enough? From here I'll just open these brackets and this will be equal to sine square A plus cos square A minus taken out into sine square B minus cos square B upon cos A plus cos B into sine A plus sine B. Clear enough? Now sine square A plus cos square A is equal to 1 minus sine square A plus cos square, this is a plus sign over here, because we take minus sign outside, so this is sine square b and minus cos square c, so minus sign outside. So this bracket is 1 and this bracket is also equal to 1, so 1 minus 1 is equal to 0. So this is equal to 1 minus 1 upon cos a plus cos b into sin a plus sin b. So 1 minus 1 is equal to 0. So this is equal to 0 and RHS is equal to 0. Hence LHS is equal to RHS, and it's hence proved.